Welcome to True Projects. In this video, we are going to explain about the project, which is an innovative ensemble deep learning clinical decision support system for diabetes prediction. Before getting into the execution, first let us understand what is the project about. Diabetes mellitus, which is commonly called as diabetes. It is a long-term condition where the body struggles with handling blood sugar levels properly. It happens because either body doesn't make enough insulin, which is like a key that helps sugar enter out cells, or it doesn't use the insulin effectively. Now the problem is when sugar stays in the blood for too long, it can cause damage to various parts of the body. And according to the World Health Organization, that is WHO, over 420 million people globally deal with this condition. That's a huge number. Diabetes isn't just about managing sugar. It can lead to some serious health complications like heart conditions. It may lead to heart failure, kidney failure, or even things like foot ulcers. So these issues they can really affect how someone lives their day to day life, and in severe cases it can even lead to death. What makes this even more alarming is that diabetes is becoming more and more common worldwide. So, catching it early and managing it well is super important. With the right tools and strategies, we can help to reduce the risk and improve the quality of life for those affected. Traditional methods which are used for diagnosing this diabetes are helpful, but they have their limits. These older approaches they often use some machine learning techniques, which are good but not great at spotting really intricate patterns in the data. Think of it like trying to solve a puzzle with fewer missing pieces. It is hard to get the full picture. Because of this, they might miss the early signs of diabetes or not be as accurate as we need them to be. So here the thing is we need a better tool. If we diagnose diabetes earlier and more precisely, we can step in sooner to help people manage it and avoid complications and live healthier lives. That's where advanced technology comes into the play. So here by using artificial intelligence with machine learning models, we can integrate smarter systems that aren't just accurate but also adaptable to different types of data and manage diabetes, making care more effectiveness for everyone. So, to overcome all these issues, in this project, we are building a technique called Ensemble Deep Learning Model, which means it combines multiple advanced deep learning models to make predictions. These models include artificial neural network, long short term memory, and the convolutional neural network. Now, instead of using these models separately, here we stack them together in a way that makes final predictions better. So, this stacking method involves meta level models like stack ANN, stack CNN, and stack LSTM, which helps to capture more patterns in the data and improve how well the system works. And in this project, we are using the real world data sets, which are PIMA IDD1, DDFG, FHG, and IDPD1 to train the system. And the algorithm called extra tree classifier to extract to pick out the most important features from the data. Once everything is trained, the system is tested using various performance metrics to ensure it's highly accurate, and the results show that the system does a great job at predicting diabetes compared to the other models. To make the system even better, we have incorporated another ensemble model as the extension of this project. So here we are incorporating two ensemble models. One is voting classifier and the other one is CNN with LSTM. So this basically means combining predictions from multiple models to come up with a stronger, more reliable result. In this case, we have used two advanced techniques. One is voting classifier and the other one is CNN with the combination of LSTM model. So by blending the strengths of these models, the system becomes more accurate and robust, which is super important when we are dealing with something like diabetes prediction. On top of that, we have built front end using Flash framework. So we have built front end using Flash framework. So this is a website. This is a simple website or an app where users they can input their details and get the predictions instantly. And we have also added secure login features by implementing the user authentication mechanism. So by this, users they can securely store their user registered data. So their data will be protected securely. Moving on to the implementation part. To implement this project, we have followed the steps of the flow of work. So first, we have imported the required packages. This step involves loading the necessary libraries that are Python libraries required for tasks like data processing, visualization, and model building. Coming to exploring the dataset, here we analyze three datasets that are PIMA ID1, DDFHG, IDPD1. So these are the datasets explored to understand the structure, features, and data distributions. Then we perform cleaning, normalization, and transformation to ensure data is ready for model building, where we do data processing. The next step is data visualization. Here we use plots and charts to explore relationships and trends in the data, helping to identify important features. The next step is selecting the X and Y data. Here, we separate the data set into, input features into X variable and the target variable to Y for prediction purpose. Then we use extra tree for feature selection. So we use extra tree to select the most relevant features from the data set for improving the model efficiency. And then we split the data into training and testing sets. Training is used to train the model, testing is used to evaluate the model. Then we define the structure of the predictive models using various algorithms, and we train the models on training data and optimize them for accurate predictions. And we compare them using accuracy, precision, recall, and FN score, and we compare them through graphs. Coming to the front end part, we have used Flask framework to build the front end. And we include secure registration and login system using SQLite the database. So in SQLite the database, all the user details will be stored. And users, they will be giving input feature values in the front end for detecting the diabetes, and that input will be pre-processed at the back end, and it will be fed with the trained model, and then we will be getting the prediction. Finally, outcome will be displayed through front end whether the person has diabetes or not. So this is how we implement the project. Moving on to the algorithms used. These are the algorithms used in the project. This is the extension model, and this is also the extension model. And here we have the requirements. To implement, we need hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. These are the source code files of the project. Let us understand each of them. How will they be used in the project? Here in the dataset data one folder, we have one type of dataset that is used in the project. So these are the features that impact the diabetes. So based on these features only, we will be detecting the diabetes. And this is the outcome, that is the target column where the person has diabetes or not. Now let's close this. Similarly, we have the other data set with the same features. So this is the other data set with the same features. Let's close this. And here in this diabetes data set, we have one more data set. So total, we are using three data sets in this project. So these are the features that impact the diabetes of the person. So based on this, we will be categorizing whether the person has diabetes or not. So here we have two classes. One is negative and positive. Negative refers to the patient has no diabetes, and positive refers to patient has diabetes. Let's close this. Let's get back. And here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook files. So these are the Jupyter notebook files, which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So in this data one Jupyter source file, here we have loaded the dataset 1, and then we have trained the models on dataset 1. Accordingly, dataset 2 and dataset 3. And here we have algorithm information, model folder, model file, in which we have the algorithm information that will be loaded into the project code during runtime of the application. Here in the sample file, we have the test cases that we will be using in the front end to predict the diabetes. And this is the signup.db file. This file is a database file which is used to store the user information. Now it's time for execution. So copy the path of the code folder from the address bar of the file explorer. I've copied it. Now open the Anaconda prompt. So here Anaconda prompt is open. Now give the command cd followed by the space, paste the copied path, and now click on enter. Here if you observe, current directory is changed to the code folders path. So by giving the command cd and by pasting the path, it will be changed to the code folders path. Now give the command python space app.py to compile the app.py file. Now click on enter. So by giving this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running, app.py file, that is after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. This is the web page of the project which is displayed in the browser, and this is developed using Flask framework. Now we need to register first. Click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password, and now click on login. We have logged in successfully and we are redirected to prediction page of the project. So here we are using three data sets. So we will be doing prediction for all the three data sets. Let's do prediction for the first data set, that is data one. Click on that. So here you can see parameters, right? These are the parameters that we are supposed to enter to predict the diabetes. So the first parameter we have is the glucose. This measures the concentration of the glucose in the blood. It's a key indicator for detecting diabetes. Coming to age, it represents the individual age, as the risk of diabetes often increases with the age. Coming to BMI, that is nothing but body mass index. It's a measure of the body fat based on height and weight, which can indicate obesity, a major risk factor for the diabetes. Then we have is the diabetes pedigree function. This evaluates likelihood of the diabetes based on family history and genetic predisposition. Coming to pregnancies, so this refers to the number of pregnancies a person has had, as pregnancy can influence diabetes risk. Coming to blood pressure, this records the diastolic blood pressure, that is mmHg. A high blood pressure is often associated with diabetes. Coming to skin thickness, this measures the thickness of the skin fold, which is in which can indicate body fat distribution. Coming to insulin. Insulin, this reflects the amount of insulin in the blood, as abnormal levels are linked to diabetes. So this is all about the parameters of the data set one. Let us enter them. So to enter, we have them in the, we have test cases in the sample file. Let's open the sample file. So here in the sample file, we have total three sheets. In the first sheet, we have test cases of data set one. In second one, we have data set two. Similarly, for the third sheet, in the third sheet, we have test case of data three. Now let's enter the parameters. So total here we have two classes. 0 refers to no diabetes and 1 refers to diabetes. Let's try predicting using the first test case, where glucose value is 124, age is 26, BMI, that is body mass index, is 33.2. And here we have kept comma, we have to keep decimal. And then diabetes pedigree function is 0.305. And then pregnancies are 3, blood pressure is 80, skin thickness is 33, and insulin value is 130. Now click on predict. So this input will be pre-processed at the backend, and then we will be getting the prediction. So let's see what will the prediction, what will be the prediction. So here we got the prediction that predicted as patient with no diabetes. That means patient is not having any diabetes. So here class 0 refers to patient has no diabetes. So it is predicting correctly. Now let's check with one more class for the same data set. Let's check with this class, where glucose levels are 65, age is 42, body mass index is 32, diabetes is 0.6, diabetes pedigree function is 0.6, and 8 is the pregnancies, 72 is the blood pressure, skin thickness is 23, and insulin value is 0. Now click on predict. So here we got the prediction that patient has no diabetes. As it is class 0, here it is predicted as patient has no diabetes. Let's check with the one more set of features. Let's check with this one where glucose is 140, age is 48, body mass index is 42.3, diabetes pedigree is 0.785, pregnancies are 11, 80 is the blood pressure, skin thickness is 37, 150 is the insulin. Now click on predict. Now let's see what will be predicted, whether it will predict as no diabetes or diabetes. So here if you observe, we got prediction as patient is having the diabetes disease. So it is predicting correctly. Here we have class 1 and here it is correctly predicting it as diabetes disease. Now let's check for the data set 2. And also here we have the same features for data set 2. And here also we have two classes only. So first let's check with the class 1 where glucose is 121, age is 31, and body mass index is 33.6688, and diabetes pedigree function is 0.979155. Pregnancies are 8, and blood pressure is 55. Skin thickness is 0, and insulin value is also 0. Now click on predict. And here we got the prediction. So here we got the prediction that patient is suffering with the diabetes disease. So patient has the diabetes disease. Now let's check with the one more class of the same data set. Sorry, we are doing prediction for the data set 2. So we are supposed to click data set 2. So let's check with this case, fifth case, where glucose is 122, age is 22, body mass index is 29.8. And next diabetes pedigree is 0.717. Pregnancies are 2. Blood pressure is 60. And next skin thickness is 18. Insulin is 106. Now click on predict. And here we got the prediction. So let's see. Here it has correctly predicted as patient has no diabetes. So here patient has no diabetes. Similarly, if you check with all the cases, it will work out. Now let's check with the data set 3. So click on data set 3. So here also we do have some parameters. We need to enter them before doing the prediction. Based on these only we will be getting the prediction. So the first one we have is the urea. It indicates the level of urea in the blood, reflecting kidney function, as kidneys issue can co-occur with the diabetes. Coming to CR, that is creatinine. This measures the creatinine levels in the blood, which also assess the kidney function and possible complications of the diabetes. Then we have is the HDL, that is high density lipoprotein. This is known as good cholesterol. Higher levels are better for cardiovascular health, which is closely monitored in diabetes patients. Coming to LDL, this is low density lipoprotein. This is another type of this is low density lipoprotein. This is often called as bad cholesterol. Elevated levels increase the risk of cardiovascular disease common in diabetes. Coming to VLDL, this is very low density lipoprotein. This is another type of bad cholesterol contributing to plaque buildup in arteries associated with the diabetes related complications. TG. TG is nothing but triglycerides. This measures the fat levels in the blood, as elevated triglycerides are as risk factor for diabetes and cardiovascular disease. Coming to CHOL, that is nothing but cholesterol. This refers to the total cholesterol level in the blood, which is important for understanding overall cardiovascular risk. Then we have is age. Age is a critical factor since risk of diabetes and its complications typically increases with the age. Then we have BMI, that is nothing but body mass index. So this indicates body fat based on height and weight, a significant risk factor for diabetes and associated complications. Then we have HbA1c, that is glycated hemoglobin. This reflects average blood sugar levels over the past 2 to 3 months, a crucial marker for diabetes diagnosis and also monitoring. So this is all about the parameters of dataset 3. Now let's enter them. Open the dataset 3 test cases. So these are the test cases that we are supposed to enter, and here we have the target. So here also we have 0 and 1 only. Let's try with the first test case. Let's copy it. Copy the urea value, that is 5.56. Paste it. Then we have CR is 74. HDL is 0.96. LDL is 1.8. VLDL is 0.56. And TG value is 1.1. Cholesterol is 4.15. Age is 49. BMI is 21. HbA1c is 4.8. Now click on predict. Now let's see what will be predicted. So your class is 0. Let's see whether it will predict as no diabetes or diabetes. It has to be predicted as no diabetes. So here we got the prediction as no diabetes. So the application is correctly classifying the person as no diabetes. Now let's check with one more case. Let's check with this case. Click on dataset 3. So here urea is 5.8, CR is 62, HDL is 0.9, LDL is 4.9, VLDL is 2.8, TG is, we have entered it wrongly. So here VLDL is 1.3, TG is 2.8, cholesterol is 7, age is 47, body mass index is 24, and HbA1c is 4. Now click on predict. Now let's see what will be predicted. It has to be predicted as patient has diabetes. Let's see what will be predicted. So here we got the prediction as patient is suffering with the diabetes disease. So this is how you need to do the prediction. Now let's check with the graphs. Click on graph. Let's check with the graphs of dataset 1. Click on that. So here on x-axis, so the first graph which we have is the sample outcome graph. This shows the distribution of target variable that we have in this project. Here on x-axis we have the target class, and on y-axis we have the count. Target class is nothing but it is the predictions that we are making here. 0 refers to no diabetes and 1 refers to diabetes. Here if you observe, 0 cases are more than the 1 cases. And this is the correlation matrix. This shows the correlation between variables of the data set. And this is the accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithm names. And these are the algorithms which are trained on the data set 1 to predict the diabetes. And this is the precision score comparison graph. This is the recall score, and this is F1 score. So these are the metrics used to evaluate all the classification models built in this project. Now let's check with the dataset 2. Click on that. Similar to dataset 1, here also we have sample outcome graph. This is a correlation matrix. And here we have accuracy, precision, recall, and F1 score. So same algorithms are used to evaluate, to build all the models, all the data sets. So the same algorithms are used to train all the 3 data sets to predict the diabetes. Let's check with the last data set. Click on graph and click on data 3. So here we have sample outcome graph. So the first graph which we have is a sample outcome graph. Here on x-axis we have the target class, and on y-axis we have all the count. N refers to negative and y refers to positive. And here correlation matrix. This is the accuracy comparison graph. This is the prediction, recall score, and F1 score. So these are the graphs. Now click on log out. In this way, just by filling the parameters which are required to the data set, based on that, we will be getting the prediction. This will help both the doctors and also the diabetes patients to diagnose early the diabetes, whether the patients they have diabetes or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.